Alright, so I know I kind of already gave you guys a little preview into the ellipses, but I do want to give you guys all the vocabulary and the proper name for it, and then we'll go on to some examples, okay? So, first things first, let's draw an ellipse, and then let's label everything. So if you have colors, I would pull those out too. Alright, so I'm just going to draw a normal kind of ellipse here. Does that look like an ellipse? Good enough? No? An ellipse is allowed to be skinny. I know you guys will have some very skinny ellipses. I just want to make sure you guys realize it's not a circle. That's why I'm trying to make it as dramatic as possible. Alright, so here's an ellipse. Okay? And it still has a center. Okay, that doesn't change. Okay. Does anybody remember from, I guess it would be over a year ago now, what letters we use for the center?
H.
H and K. Okay, very good. So that doesn't change. This center is still H and K. I'm going to write H, comma K. Okay, so that doesn't change. Now what does change is that we no longer have that perfect radius to just say, oh, it's just going to be x minus h and the y minus k and equal to my radius squared and all that fun stuff. It's not as simple as that. So we actually have two sets of vertices that we have to look at that help shape our ellipse. So the first one, I'll put in green. These are our vertices. It's our vertex. Okay. Now, our vertices are always going to be along our major axis, okay? So we have two axes here. We have a major one, which dictates what kind of shape it's going to be. For example, the major axis for this one is horizontal. If I had switched it and put my two green dots at the top and bottom, now my major axis is vertical. Okay? All right. So the other thing we have is a major axis. I'm going to write that the vertices are always on the ends of the major axis. Now, what can you guys assume about the center compared to the major axis? The center point of the ellipse is going to be what?
The middle of it.
Yeah, the middle. It's the midpoint, yes? So if you know the distance from the center to the vertex, can you find the distance from the distance of the whole major axis? Yeah. Okay, so the distance from the HK to the green vertex points was 5. Then my orange line has a length of 10. Okay. All right, so we have our major axis, we have our vertices. To make the other shape, so how high I go, or how much of it is going to be like shaped like a football compared to a circle. As you guys said, it looks like a football. Okay. We have what we call our co-vertices. So you call it a co-vertex, or co-vertices would be pro. And the co-vertices are always on the end of the minor axis. All right, so does everybody see how we have a major and a minor axis? The thing to remember between them, the major axis is the one that tells you what shape you're going to have, whether it's horizontal or vertical. Okay? That's the key here.
The one in the middle, right? Going down.
Yeah, it will always be the biggest line. Your major axis will always be bigger, no matter what. It's always the bigger number. It has to be. Okay?
So is there like, is the covertex always like two, well the major axis is 2 times the covertex?
No, we don't. The major and the minor don't have anything that compare to each other. Yeah. All right. All we know is that the major and the minor are perpendicular to each other. They form a right angle. So those are your main labels. Okay, I want to make sure we're using the proper vocabulary. I have one other thing that relates to the presentation that I did in the beginning. And these are always located on the major axis. Anybody remember what I called them? Remember the blue thumbtacks? What did I call them?
Focus point.
Focus points. The foci. See, I made them blue. That's why you saw me when I used blue earlier. I erased it, okay? All right, so my thumbtacks. Those are called focus points. Or if you want to say focus points, you can say foci, which is and like that. That's, you know how you say cacti and cactus? Cacti is plural, cactus is singular. Same thing here. Focus is singular, foci is plural. Okay? Foci. Alright, so the foci are always on the major axis. Okay. So if you know where the major axis is, then you can find your focus points. Oh, I see some people trying to reach overhead. All right, questions about the vocabulary, about what each part is called. Great, let's actually get into the math now. So I'm going to redraw an ellipse. Oh, that's too much of a circle. All right, so there's my ellipse. Now I'm going to redraw my points here. So remember correctly, these were green, yes? So the distance from the center to the vertex, we call A. Okay, now I'm going to start giving you guys variables and letters and whatnot. Okay, don't get this confused with the Pythagorean theorem, please. All right, and then we have the distance from here to here as B. And then the distance from the center to our focus, what letter do you think it's going to be?
C.
It's C. Okay. Alright, so the reason why we need these is because when I give you guys the formula of the basic setup for an ellipse, our issue becomes that we don't know how to find the distance for our focus points. So we have to use the A and the B value to find our C value. So it works like this. To find our C value, all we need to do is to take our A squared and subtract the B squared. Now, if you guys Google it, some people tell you that it's actually A squared minus C squared equals B squared. I have done the math for you and put it in this format, okay? So that you guys will always be able to immediately have it ready to go for your C. Okay? So this is the formula that you use to find the distance from the center to the focus. Okay? Questions about ABC? Alright, so when talking about the formula of an ellipse, this is something that you guys have seen before. You guys saw this for circles. Only it was set equal to the radius squared. So what changes for an ellipse is that it's set equal to 1. And we have to calculate the major and the minor axis in there. Okay? So for this one, I'm going to actually divide both equations. One of them by my b value, and the other by my a value. So this is how the ellipse changes slightly. And that should make sense because we have those two axes that are working together to change the shape of that perfect circle. So they should be in there somewhere. Okay? Somewhere. Okay? Alright. Alright. So what do you think would happen if I switched my a squared and my b squared?
It was like 0 away.
Okay, we'll turn it the other way. So right now the formula that I have presented is the fact that my a squared, my a value, don't touch it.
Oh, I'm about to touch it. I ain't want you to cut my hand off.
My a value is under my x's, okay? So what this means is that my largest axis, that orange color, is going left and right with my x's. Now, if I put my a under the y's go up and down. So, therefore, my major axis would now go up and down, okay? So, I'm going to say that this is horizontal. And then I'm going to rewrite it for you, and I'm going to say that that one is vertical. This way, you guys always know the difference between the two. Yeah, just switch the bottom. So now you see how my a is under the y's? So my bigger number is with the y's. So if the bigger number is with the y's, then the y's go up and down, therefore the bigger number is going up and down. Okay, do you guys understand that a is the major axis? Do you understand that the major axis dictates whether it's a horizontal football or a football standing on its tip? I heard a no. So horizontal would mean that it looks like this. Vertical would mean that it looks like that.
So how do you know
Okay, because the biggest number will always dictate your a value. So let's say that my a squared is 16. If I have it under the x's, then I know it's horizontal because it's my biggest one. We'll say b is 1. If I have my 16 under the y's, now it's vertical because it has to match my y values, which go up and down.
Wait a second. The horizontal one is the A, and then B, and then the vertical is the B and then A.
B and A, yeah.
Okay, guys, think about this for a second.
And the B is minor.
Do your x's go up and down or left and right?
Left and right, they're already.
I'm going to ask that again. Do your x values go up and down or left and right? Left and right. So, if your biggest number is under your x's, you have a horizontal shape ellipse because it has to go left and right.
How do you know the X and H or Y and K?
It's already been given.
It's already been given to you.
Oh, okay, that was my question.
It's already been given to you. Okay? Yep.
The first formula you wrote down, was that for the vertical or the horizontal?
That's horizontal.
And the second one?
Yeah. Okay.
Wow, that was a stupid question.
That's okay. I wrote it up there. I was just, right, any other questions about the formula? Do you guys remember H and K is your center? Because we've already talked about it, but okay. All right, let's do an example then. What? What?
Let's talk about it.
So, example 1. What's the issue with the example I just gave you?
It's not over anything.
It's not over anything. It's not set equal. Somebody else set it
One.
to 1. All right, well, how can I get the 400 to become a 1? Divide it by itself. Okay, so if I divide this by 400, what do I have to do to all the others? Yeah, see? There you go. I just reviewed some basic algebra for you guys, for those who are taking the SAT soon. All right, so let's simplify these. How many, let's do this one first. It's going to be easier. How many quarters are in $4?
4. Whoa.
16, okay.
12.
You said 4. I was just wondering. All right, so therefore, do you guys understand that if 400 divided by 25 is 16, then 400 divided by 16 must be 25, okay?
Wait a second, what did you just say?
I swear.
I said how many quarters are in $4, and you guys said
I
4.
thought you
They say $8.
It's okay.
Everybody was like, 4.
I know. I know it doesn't look like we have an H and K there, does it? It's 0. There is no H and K in this case, so it's centered at 0, okay? Well, do I know if this is horizontal or a vertical ellipse?
Yes.
Which way?
It's horizontal.
25 is bigger.
There you go. So the 25 is the biggest number. It's under the X value, right? Which means it goes left and right, therefore it must be a horizontal shape. It must be a football on its side, not on its tip. Okay?
Will there ever be a case where both numbers are?
Okay, so
That's like,
this number right here, 25, is bigger than the 16. Therefore, I know that this has to be my A.
Wouldn't it be vertical then?
No, it's horizontal.
Did I do this wrong? Did I write
Yes, question, Rick.
will there ever be a case where
They're the same?
it's, yeah,
Because then it would be a circle.
I know that I wrote it wrong.
All right. So now that we kind of talked about this, let's start writing down some information. Let's go ahead and find all of our stuff. So first thing is the center, which Rena told us was 0, 0. There is no H, there is no K, therefore it must be 0, 0. Okay? You guys also told me that my A value, I'm going to say A squared, is 25. And my B value is 16, my B squared. So how would I find the non-squared portions? Square root it. Okay. That's what she meant. She meant to say that. All right, so we know our A is 5 and our B is 4. So this tells me that the distance from the center to the vertex is 5. And the distance from the center to the co-vertex is 4. Okay? It's going to be 25 minus 16. You do the square root. We'll get into that in a second. All right, so real fast, I'm going to sketch a picture. You guys will not be required to graph today, but some of my visual learners really need that graph to see. Okay? So I'm first going to go ahead and plot the center, just like we did with a circle. There's my center. It's at the origin, 0, 0. All right, now we know it's horizontal, so my A is going left and right. So I need to go left, how many? 5. I need to go right, 5. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's my A value. Those are my vertices. Because this is my major axis. The distance from here to here has to be 5. That's my A value.
so you're going to go up on the y-axis 4,
Okay, so I'm going up 4.
you're going to go down 4.
3, 4. 1, 2, 3, 4. All right, those are my co-vertices, yes? So now I have my wonderful, wonderful ellipse that I can draw here. And this one's pretty close to a circle. I would say it's pretty close. But we know it's not because the distance from the center changes. It's 4 for the purple and 5 for the green. Therefore, it cannot be a circle. Okay? It would have to be 5, 5, 5, 5 all the way around for a circle, or 4, 4, 4, 4 all the way around. All right, so now we need to find my focus points, my foci. So I told you guys that you could find that by just going c squared. So it would be our a squared minus the b squared. So the biggest thing to remember is that you take your a squared and your b squared, your denominators, and you subtract them. Don't take a and b. Yep. So 25 minus 16, which is 9. Then you take the square root, so it's 3. So my focus point actually ends up being here and here. And it's always on your major axis. So wherever your A is, your focus follows. Okay. So I didn't ask you guys to graph. You guys are supposed to tell me the coordinates of these, yes? So what's the coordinates of my vertices?
0, 5,
All the way around.
5, 0.
5, 0. So that would be this one. That's 5, 0. What about this one? Negative 5, 0. Okay, so let's write that down. So our vertex is going to be negative 5, 0 and 5, 0. All right, what about our co-vertices?
0, 5, and 0, negative 5. 4.
Okay, so now it's 0, 4 and 0, negative 4. Might help if I put my color back on. And then my focus points are at the negative 3, 0 and the 3, 0. So basically you guys are taking the center value and you're adding and subtracting whatever your A and your B is. Yes? And since this is horizontal, I know that my x's change for these two. And since it was horizontal, I also know that my y values changed for my co-vertex. Okay? I mean, this wasn't too bad. When the center's at 0, it shouldn't be too bad of a problem to do. All right, first thing. Let's start off easy. What's the center?
2, negative 5.
Do you switch the signs?
We got to switch the signs.
So negative 2, 5.
Okay. Whatever.
So remember when you guys have minus in front of a variable, it means take the opposite of. Okay, in our formula, it was x minus h, so the plus 2 has to be a negative 2, and the minus 5 has to be a positive 5. It's a good review from the circles. I didn't mention that before. I want to see if you guys remember. All right, so let's go ahead and start with finding my a and my b. So my a is the 4 or the 25? My a squared.
25.
The 25. Which means that my a must be 5. And my b squared is 4, so my b is 2. So far, straightforward and easy?
Yeah.
And I can go ahead and find my focus length right now as well.
How's d squared?
So it's the biggest number.
Okay.
So I can go ahead and take the 25 minus the 4, get 21, then take the square root. So I know that my c is square root of 21.
Why did you pull the 25 before?
Oh, remember you always go c squared is going to be equal to your a squared minus your b squared? All right, now here's the thing. So my 25 was under my y's. So is this going to be horizontal or vertical? Vertical. So I know that my major axis is going up and down. Okay? So here's the thing. My center isn't at 0, 0 anymore. Okay?
It's at negative 2, 5.
So I need to actually think about what's going on. My y values are changing for my major axis, yes? So it means that whatever my vertices are going to be, I know that my negative 2 has to stay the same. They're not supposed to change because I'm going up and down, so my y's are changing, yes? All All right, so let me draw a picture because you guys, some of you can't see that. All right, so there's my center. I got to go up 5 and down 5 for my major axis, for my vertices, yes? So 1, 2, 3, 4, 5. It's the very, very top. 1, 2, 3, 4, 5. So did my -2 for my x value change?
Sorry, why do you have to do the last?
Because that's my a value. So my -2 doesn't change. My x value stays the same. Only my y is changing. So the coordinate for this one would be just -2, 0, because I subtracted 5 from the vertex. And this top one is going to be -2, 5 plus 5, 10, because I'm adding 5 to my center.
How do you know where to put these numbers?
All right, so then to get my b value was 2. So I would have to go 1, 2 this way. 1, 2 the other way. So now my 5 isn't moving, right? Of my center. Only my x's are changing because it's moving left and right. Some of you are going to have to draw a picture every single time. Some of you can do it in your head. I don't care which way. Okay? Sketch a picture if you need to. All right, so to find the focus length, what's the square root of 21? I was going to say it's 4 point something. Okay, so we know that this is about 4, I'll just put 4.5, it'll be easier to estimate, okay? 4.6, it's the same thing. So to find my focus points, I have to add and subtract 4.6, 4.5 to this 5 value, okay? Which is why I'm cool with you guys doing decimals this time around. Okay, so if you can't figure this out algebraically, then let's just go ahead and look at the picture. Yeah, go ahead. All right, so I need to go up 4.6-ish, so 1, 2, 3, 4, so you're right here, and down. So it should be really close to 0, and it should be really close to 10, which is how we got the 9.6 and the 0.4. That should make somewhat sense there. If you need to draw a picture, sketch a quick picture. I'm cool with that. Okay? All right, last thing. To find the length of the major and the minor axis, all you need to do is double your A and your B. Okay? So I know the length of my major is going to be whatever 2 times my A is. So it's 2 times 5, which is 10. I don't expect you guys to write all that work. Just double it. Because we know that the distance of A is from the center to the vertex, right? So we just double that length. It's the midpoint. Okay? So the minor, we go 2 times the B. So it's 2 times 2, which is 4 in this case.